Right, so this is section 4.3, but this time we're going to be solving application using the elimination method. So I thought I'd go to page 289. This is a common problem that a lot of students have on the homework, and they find this really frustrating problem to do. And so this is 61, river current. A riverboat takes 8 hours to travel 64 miles downstream and 16 hours for the return trip. And they want to find the speed of the current and the speed of the riverboat in still water. So this is the problem. So now let's go to the clear screen here, and let's make an important list. Okay, so I'm going to make an important list. Okay, so what do I know so far about this particular problem? Well, it says that the riverboat is going 8 hours to travel. So it has 8 hours to travel 64 miles. So 64 miles. And it says downstream is 16 hours, and for the return trip, oh sorry, 64 miles for downstream. So this is downstream. And then it's 16 hours uh, for a return trip. So 8 hours to travel 64 miles downstream, and then 16 hours for a return trip. So 16 hours for a return trip. I have trip. Okay, so obviously it's going 64 miles back. Okay, so let's make a table. Okay, let's make a table. So here's my table, because I need to make sure everything is pretty clear in my head. So here's my table. Okay, and so I'm going to have a category. So a category, and I guess I will call that the upstream. Okay, so we have up, and then we have down. This is the stream. Okay, and then I'm going to go a rate, because I need to know a rate on this, and that's the part that most people don't think of. So going up means it would be x minus y, because as I'm going up, I'm being pushed by the current. So it would be x minus y. And then going down, I would be adding the current to me. So that's what that does. And then your time, well, they told us it was what? It was basically 8 hours and 16 hours. So 8 and 16. And then distance. Distance. Oops, a daisy. I didn't spell distance right. So distance here. Okay, and so my distance um, for this one is 64. Okay, so that's taken care of right there. Alright, so now I can set up my equation. Just remember the distance is going to be equal to the rate multiplied the time. And so I know my rate, which is rate equal to distance divided by time. So that would make the distance divided by time for here. So for my first equation, I'll move this down a little bit so we can see it. It's going to be what? X minus y equal to 64 divided by 8. And then the other one, x plus y, which is equal to, wait a second, I have messed up. This should be the other way around. Okay, because it would take me less time with the current than it would against the current. So this should be 16. So this should be 16, and this should be 8, right? That makes more sense because it would take me less time to go down the stream than it would be to go up the stream. So x plus y is, and then I'll delete that too. So this would be going up would be 64 over 16, and then this would be 64 over 8. So we can simplify that as x minus y equal to, and 64 goes into, or 16 goes into 64 4 times, so that'd be 4, and then x plus y is equal to 8. So now I can add my equations together, so I get 2x equal to 12, so x is equal to 6. And so far I know that my x, which I am terrible, I did not define what x was when I should have. So x is the still water, right? That's the speed of the boat in still water. So that's the speed of the boat and in the still water. And then y would be the speed of the current. Okay, so now let's take a look. So I got x, so x turns out to be 6. Okay, and that's 6 miles per hour. And now let's find what it is for y. So for y, I got to go back to one of these original equations. So I'll put 6 back in for x. So 6 minus y equals 4. So minus 6. So y is going to be 2 in it. So that's 2. And so for the current, it's 2 miles per hour. Okay, so I have 2 miles per hour for the current and 6 miles per hour for the actual speed of the boat. So for the boat. Okay, so this tells me how I solve it. So one thing that's important is when you're making your important list, that sometimes it's good to make a table so you can organize things. This typical problem does show up in the homework, so I thought I would do this one. It seems to cause a lot of heartache with a lot of students. So here you go.